Hello, Internet. My hair is doing something kind of exciting today. Programming video. Thing came up at work that happened to tie in to another thing? I don't know. Let me just start talking. So, there is a thing from programming, this idea that I've known for a very long time. So long, I don't even remember like how it got there. Like, where did I learn this thing? How? When? I don't remember. But it's this idea that and it applies especially to I've been doing web stuff for so long. It especially applies to web stuff, but all kinds of things where you're dealing with data. Information's coming in, and the idea is this: when you're taking in information, kind of assume the worst in a couple ways. A, that maybe the data is just kind of badly formatted, has some mistakes, blah blah blah. And so look out for easy things and clean them up. So like an easy example would be extra white space on the side. Like, so you're expecting an email address or a phone number. Maybe there's extra space characters on the beginning or end. Obviously there aren't spaces in phone numbers that way, but you can be a good programmer and say, hey, I'll clean those up. But also look out for maybe people trying to do bad things. Like, maybe you're only expecting an email address, but you just got like a gig of data. Like, you don't want to just get that whole gig of data and then try and do something. You're going to overwhelm your system. So look for bad actors or just mistakes in general. Just be thorough and forgiving, in particular when you're dealing with data coming in, and then for data that you produce and send out or store, be as like adherent to any specifications. Be tidy and good with your output. So accept messes and produce non-messes, right? So I Googled around, and again, this came up at work. And I was Googling because, what is this thing called? Why do I know this? And it's called the robustness principle. It also, and I love this name much better, it's called Postel's law. I don't know why. That's just like having a name in there makes it sound so much cooler to me. I don't know if it's just like my D&D rotted brain where, look at this. Mordenkainen's faithful hound. They could have just called it faithful hound, but they called it Mordenkainen's faithful hound, which is obviously a cooler name. And I think Postel's law, we can all agree, is obviously a cooler name. Obviously a cooler name than the robustness principle. But anyway, and is named Postel's law because it's named after a guy. I didn't know this. Again, I was Googling all this. And I'll link to the Wikipedia article in the description. Named after a dude, John Postel, who was writing the specs for TCP. And TCP, if you don't know, I think most people know what an IP address is, right? We all have IP addresses. It's those numbers separated with dots. That's what identifies. There's complexity there. We'll just say it identifies your computer on the internet. There's some complexity there. That's not 100% true, but generally. But on top of that, so IP addresses just say, well, here's how you know where people are and how to send the data. But then TCP on top of that says, here's like an additional structure for that data to add some additional properties. So that if you're sending out a lot of messages, the receiver knows if they missed one, make sure that they get them in the right order, whatever. TCP adds all these other features. So anyway, the guy writing this TCP protocol, this was, I guess, where this was first. I don't know. This idea came from this robustness principle, and he said, I'm looking at the quote here, but it's be conservative in what you do, be liberal in what you accept from others, or be conservative in what you send, be liberal in what you accept. So that's Postel's law. And he has, and I love this quote, this other quote, he says, assume that the network is filled with malevolent entities. Well, that sounds like straight out of D&D as well, that will send in packets designed to have the worst possible effect. So this is closely related to another concept in programming, never trust user input. That is a phrase you can Google about and find lots of people talking about. And it applies to everything. Web forms, like just because you ask for a phone number doesn't mean someone's going to type in a phone number. What if they type in more than you wanted? Just because you said HTML input max length equals 20, people can change that. So check your user input and make sure. Assume that there are going to be some people trying to cheat or abuse or take down your system or whatever. But also the thing he was talking about is be forgiving in your inputs. So this came up at work. Because of spaces, like I was saying, where we have a file upload. People are going to upload this file. It's a CSV file. May or may not be familiar. It doesn't matter. But it might have dates, and there might be spaces on either end of the dates. And the question was, shouldn't we, be nice and sanitize those? Another example that comes up a lot, and this is going to tie into something else, a more complicated, because that's easy, right? That's an easy example. Take off the spaces on the end, unambiguous, no problem, right? But a more complicated example would be HTML. I don't know how familiar you are with HTML. Here is an HTML example. So, you've probably seen this around before. If you don't, I don't know why you're watching these videos. So here's a paragraph tag, right? We're saying here's a new paragraph, here's some text, and then we're going to start making, let me come from above, we're going to start making the text bold. Here's the text, and here's a comment for people below who know we don't use the B tag anymore. I know that too, I promise. But it was, shorter text. As you can see, I already ran out of space, so I'm glad I didn't try to use strong or whatever. But anyway, open the bold tag, some text, close the bold tag, close the paragraph tag, right? That's the specs. You close these things. But the specs are built with robustness in mind. They're forgiving of input. What if you miss the closing bold tag? The specs say don't be crazy and just run the bold out into the rest of the page. Clearly that's not what anyone expected. You ended the paragraph tag. So we'll end the bold there too. It goes even further. You don't even have to close the paragraph tag. You could say paragraph blah, 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 bold. Don't even close the bold. Don't even close the paragraph. Start a new paragraph. In that case, browsers know, because again, it's part of the forgiving specs, the robust specs, to say they started a new paragraph. We don't allow nested paragraphs, so just assume that they close. We're closing the previous paragraph. Something I didn't really think about, even though trying to go two directions at once. So let me just pick one and then we'll hop to the other. So first direction, it can get very confusing. This is only two tags. It's pretty easy to see how you could figure that out with the browser. I haven't run into this issue as much anymore. 20 years ago when we were handwriting more HTML, you still do, but I feel like there's all these nice JS and JavaScript frameworks that do work for you, or Blazor even, C#. But it can get really difficult, right? Because one mistake in your HTML, maybe everything's fine. Two mistakes, maybe it still renders properly. But then suddenly you add a third or a fourth, and then you start getting a weird effect on the page, and you're like, whoa, what's going on? And it's really hard to debug because so many things had to compound, and now you're looking at this code, and you're like, this is all madness, or well, which one of these is the problem? How come when I fixed this, it didn't seem related, but it fixed this other thing? It's hard to explain without a concrete example, and it's been so long again since I really ran into debugging HTML. But it can happen, and that is one of the criticisms that I wasn't aware of that people have on the robustness principle. Again, on this Wikipedia article, two criticisms stood out to me. That was one of them. It makes for systems that are harder to debug. So by being very forgiving in the inputs, maybe it takes a bunch of different problems before you finally notice the problem, and then by that point it's harder to debug. So that is a potential downside to the It's like, I never thought of that. I've encountered that problem before, but I never kind of tied that into the robustness principle. So I thought that was Postel's law. Let's use a more fun name. Postel? I don't know how you pronounce his last name. Another criticism, which I thought was really interesting because I had just been reading about this recently, and the Wikipedia article doesn't name this, but it's another law name with a fun person's name. It's Hiram's law, which also sounds like it should be out of Dungeons and Dragons again, so love it personally. So Hiram's law is that if there is some sort of interface like this, and by interface I don't mean like a user interface, but just any kind of again, you've got a form and people can submit phone numbers and it's going to take out, that's an interface, right? You've got this interface as I take these inputs. If you have an interface like this, Hiram's law says, any implementation details, even if they're not part of the spec, so let's say this white space thing wasn't part of the specifications, no one said to do this, but you were a good programmer and you said, I'm going to take out the white spaces. It's an implementation detail. People will come to depend on that. They will de facto become the specifications, even though they were never supposed to be part of the specifications. And I think white space is a particularly interesting example. And so I keep saying white space. So there are space characters, right? You could just have press the space bar key on your keyboard, you're going to get a space character. And there can be spaces on either end. Let's say you copy the phone number from a web page, right? You might accidentally copy an extra space from the beginning or end, but we all know it's okay. You can put in the space character. A lot of languages have a trim function. It's almost always called trim in all the languages, and you can give it any text. You say trim this text, and that means take all the spaces off of the beginning and end. But it's not just spaces. There are lots of characters that are white space because paper. What would move? What would create some blank space on the page, basically, right? It could be a space character, but it could be a new line where you go down to the next line. It could be a tab, which is some extra length, right? It's a wider space, basically. There's a non-breaking space character. It comes up in HTML a lot. So if you have two words and you don't want them to be automatically wrapped ever, you're like, no, it's important for readability that these two words be close together. I'm putting a non-breaking space in between. I feel like people used to use that a lot for table headers. They probably still do, just to make sure that they don't get broken, as columns shrink or whatever. And then you go to other languages, and there's all kinds of other characters. So anyway, as a programmer, you might say, oh, I'm just going to trim the spaces off of the end of this. That's what you're intending to do. So you call this built-in trim function. Well, that built-in trim function might be super smart. It's actually trimming tons of extra, white space characters you weren't thinking about. That's an implementation detail that conceivably could accidentally become something that someone depends on by being forgiving on the input. So suppose you've got this thing that takes a file upload. It might not be humans uploading files. Maybe there's another automated system built by you, built by someone else that you work with, who knows, and they're uploading files. They might not be super clean about their outputs, which is why you're being forgiving in the first place. So I don't remember which side was the inputs and which was the outputs. I think inputs were over here. So they might not be super great with their outputs. So they're producing maybe extra new line characters, but your system has always worked. It's always been okay because you've always trimmed out new lines, even if you didn't necessarily intend it. Implementation detail. You're trimming all those out because your system is so nice and forgiving, and then later on maybe you go through and you're like, oh man, we didn't need to be that. Maybe there's some reason why you want to treat new lines special and you don't want to do that anymore. And that was never supposed to be there. It wasn't part of the spec, so it's okay. No one will have, we're not going to break anything by removing that. It was never part of the spec. Well, it is de facto the spec. You had that there. It lived for a long time. You were very forgiving with your inputs. Everyone has come to assume that, and now you can't change it. That's Hiram's law. And it was just interesting to see. Again, I had been reading about Hiram's law recently. I don't remember why. I think I just kind of stumbled on it while I was looking at little programming rules of thumb. So it was very interesting to read on the robustness principle, or I've named Postel. Got to go back and look at it. Postel's law. Just interesting to see that as a criticism that by being very forgiving with your inputs, you might accidentally, create this contract you never intended to have with the outside world, with other people using your thing. So I don't know. I just thought it was very interesting. I do think in general, actually I have two extra thoughts, and again, two different directions. So let's pick one. I'll go back to the other. First thought. I would still use Postel's law, to use the more fun name, and be very forgiving with inputs. I think that's a fine default. You want your interfaces, again, to use the term very generally, you want your interfaces to be ergonomic, easy to use for other people, whether you're writing a library of code with functions that you're going to give to other developers. You want it to be really easy for them to use and just kind of work, right? Or when you're making HTML in the early days, it was like humans will be typing all this HTML, so we want to be forgiving of their mistakes because we want them to use this technology. It's so let's make it easy to use. So there are a lot of reasons to want to make your system just be easy and natural for a human to use and be forgiving of mistakes and all those things. But right, there's downsides to everything. Think about that funny that I didn't think about that interaction with Hiram's rule. I think that's very interesting. So anyway, again, I would still usually just be very forgiving of user inputs. And paranoid, right? Also the thing of make sure also they're not trying to exploit you somehow. So just check the input in general. The other thing I thought was interesting is I feel like Hiram's rule, it was written with computer systems in mind, but I think it goes way beyond that. Just as a human with our brains, right? We come to expect, and this is still computer, but it's if an application moves a button, you have muscle memory. You've come to expect that the undo button is in the location it is, or has the keyboard shortcut. And if that's ever changed, maybe that was never a promise that anyone made, but you have come to assume that. There have to be things like that in real life. And I was trying to think, what's a real life example of I don't know, what are some things that there are requirements? There's always yellow paint where you can't park, and oftentimes that's because there's a fire hydrant. But are there other things around that maybe we just come to assume, and if someone betrayed that assumption, we'd be like, hey, even though that's not part of, I don't know. I feel like there's got to be examples of that in real life. So I don't know. As I was thinking about all this, I just had this additional thought of I think Hiram's rule applies more broadly, right? It's not just interfaces for code, and applications to be using with one another. It's all interfaces, really, user interfaces, things in the outside world. Oh, I know a great example. The convention is that if you have a on a door, if there's a handle that you can't grab a hold of, then it's for pushing, and those are often a horizontal bar. And if there's a vertical bar with a handle, then you know that you can pull it. Some doors are stupid, and they have that horizontal bar, and you go to pull it, and it won't pull because you have to push it. They've fucked up. Hiram's rule. I don't know. Is that quite Hiram's rule? That might be a little bit different. But anyway, that's it. Thank you very much for watching, and goodbye.